Chris, we spoke a lot about the technology evolution, technology capabilities, but for me, the big elephant in the room, or not just big, the elephant in the room, often is the business case. Because, we don't address things, but also we only almost have a somewhat very narrow view on the impact, and we are back to the discussions, it's including change, how you train people. Of course, you could also just not narrow some of them, looking at the cost for running LMMs, but it's a very narrow view, but it has to be much broader. What is your experience? How do we look, and how do we, in the end, get to the next step of convincing people to really embrace all those innovations?
So look, we have to separate the business case of AI users and AI builders, right? Because AI builders have no business case. It sounds great if they make $2 billion of revenue while at the same time spending $100 billion. Yeah. Personally, I think it's totally crazy how much hardware we're using and how much energy, right? Absolutely. At the same time, we're talking about climate change. Yeah. From a technical point, it's fascinating. At least let's start thinking about the consequences. So the business case for companies should be fairly obvious if you just automate. Like, you automate the actual doing. If you think about this in industrialization terms, you first had manufactories, and then you had the multiplication of force. Yeah. And what you basically did was Taylorism. You split up work into single stations, and then you replaced each station with a machine. And before, in a factory where there were working 100 people on melting steel, there's now maybe 2 at the proper machine. Like now, exactly the same thing is happening to the service jobs, to the knowledge jobs, like a lawyer, a tax consultant, someone who's just working in an office. Let's call it the email jobs, right? Or fielder jobs and so on. We have hundreds of people. If you think about it, like where AI is trying to control itself, all these people that do content curation on platforms, yeah. Thousands of them, like in the Philippines or whatever, like, okay, they're not high-value jobs, and this is why they're outsourced to low-cost countries. But if you think about lawyers, all the associate lawyers that have to read all the thousands and thousands of pages of stuff, that is totally crazy, right? So that is entirely crazy. So being surprised that this stuff gets automated next, the cognitive work, the one that doesn't just involve manual labor. Actually, we found out that it's fairly expensive to build a human hand, yeah. Right? But it's fairly cheap to now, with LLMs together and reasoning, to have something that reads legislation is fairly cheap again. So don't be surprised. Exactly what happened to the people at the machines is now happening to people at the offices. And this can be very scary, right? So the business case is automate office work.
But isn't the next logical step, we have to be serious about digital labor? Again, we talked about it 10 years back, 15 years back, when the whole RPA discussion started. This was a lot of lip service, I would argue, back in the day. Isn't that becoming new reality?
But you remember what was out there then, right? These were all hoax showcases. You had the robot heads, what's his name, Sophia, that was even at World Economic Forum, and then they had the bot, Amelia, that was supposed to do anything, and it was all scripted and pre-scripted and so on. And you find this today, right? You have Elon Musk showing off human-like robots, and there's a driver in the robot, right, behind the robot. So like, what the hell? Why do we have to do this? But we have come a very long way in these terms, and we are getting to digital labor. For example, we are now combining the Bardiok reasoning engine as the execution place and the intent generation place with a voice agent that is completely AI generated, picks up the phone and says like, "Hi, I'm Paul, I'm your IT support, can I do blah, blah, blah for you?" And then the person says something on the other end, I want to do blah, and let's say they want some problem resolved. This problem gets thrown against the intent list, and with a large language model, you find out, okay, what's this guy trying to do that I know how to do? And then it says, like, you meant this, in order to complete this task for you, I will need to know that. Again, created by a large language model. And then it goes into the execution with all the possible variety, and it's not a script, it's not a bot, it's not an LLM doing it, but it's a reasoning engine creating the solution for this step by step, and then solving it. Like, this is where it's going. Like, you digitize everything.
double-clicking on reasoning, can you literally, for someone like me, do reasoning for dummies? What do we have to understand? Where is really the progress coming in? And as you know, it's close to your heart, or the development over the last couple of years. Can you just explain to the broader market what is this change, but also what's still needed? Why haven't we solved?
Look, reasoning has been around for very long, right? And basically it means the ability to judge between options. Right, so if you think that the solution to a problem is a step way, then at each step of the way to your solution, you have a lot of options what you could do next. Yeah. And the question for your logical or for your reasoning is, out of all these options, which ones make sense and which one is the best to do? And then you do. And this way, because you are not developing just the plan and then you do it, you might have a general strategy and say like, I want to keep this inside the local data center as much as possible. I want to whatever, right? Whatever you're optimizing for. You might have an overall strategy, but you don't have a plan of exactly doing things, but you create it step by step. And this means you can react to change and to unexpected events. And have a strategy is very different than having a plan. We can talk about this if you're interested. But the point is that by doing this, we get into all these judgment situations. Which one is viable at all, and which of those viable ones is the best? Now, you can do this judgment in two things, right? You can do it purely statistically. You can do it as an experiment, as a lottery. You try, and there are gazillions of parameters in your context and in what you can possibly do. So there is a gazillion of different options and steps. And this is what typically the statistical reasoning models like the O2 from OpenAI do. They just try a few million options, and then you optimize, do a statistical optimization on the better. I think what's a better way is try and logically argue why something is better. Like actually being able to say, this is better because blah, 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 not because of trial and error. Trial and error might be great in fields where there is just trial and error, like protein creation, and then testing the protein for pharmaceutical value. That is trial and error. And if you do it manually, you can do whatever, 10,000 proteins a year in a large lab. But if you do it with a machine, you can do 10,000 proteins a day, maybe, or an hour. I don't know how fast they are now. And that's, of course, great for trial and error. But generally, finding a solution and doing judgment should be an explainable thing, something where you say, I chose this option because, right? And this is not statistics. And this is where logical reasoning comes in. So in the end, you have inaccuracy, which means you're acting in a space with infinite amount of possibilities. So you will have inaccuracy. You will need the statistics at some point, but you should keep it at the back, not the front. That's my thinking. Keeping it at the front, A, very expensive compute-wise, and B, if things just work by accident, how can you build the next generation of good society, good life, good technology on top of it if you never understood why it happened? So if you're able to answer the question why, which means that you have to be symbolic and logical, then reasoning is better. Also, from a compliance point of view, I think this is so funny that a tech person like me has to argue for compliance. From a compliance point of view, as long as humans are in control, you can say, this is why this decision was made. And you don't say, I've tried 2 million random things, this was the best. Right? So you want to know why.
Who's doing reasoning well at the moment? Or is that literally also where you with Almato are trying to almost get your differentiation across?
So I think our reasoning model is doing fantastic. Right? The fundamental algorithm hasn't been changed for a very long time, and it's running stably, and it's running at much, much lower energy levels than any of the LLM or statistical-based reasoning models. I think that we also have the option of not just learning from data, meaning we can learn much smaller pieces of knowledge, things that only happen once a year, things that are statistical outliers, things that are the one thing that made this company more successful than the other. That's where we can actually adopt into the system and actually make it part of the logic that is in there. I think for us, the combination with large language models is great as a user interface. Like, how do people interact with technology? By language, because that's how they interact with people. And if we can get more people to use more technology, we broaden the horizon and we broaden the impact of technology. Right? If you don't need a year to learn how a Cisco router works, but you say like, okay, can we create a configuration for this type of network, and you draw it, and you're done.